Get ready for awesome in 3, 2, 1. What could possibly go wrong? Let's find out.
So, it keeps telling me there's an error and the stream cuts out, but it doesn't tell me what the error is, so kind of difficult to diagnose that, hey? Anyways, okay, post install, blah, 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 npm I, so we've got the new version of Zeebe node. Good. Okay, so we've got the latest version. Good. Well, let's see if it runs. And I guess the way for me to run it against... Actually, yeah, I should check my own README instructions. So, should be sufficient instructions in the README to run it. Remembering, what is this? The Middle Ages? We ain't going to remember nothing. We're just going to read the README. Okay. Even in the Middle Ages, they weren't really into remembering stuff because that's when they started writing a lot of stuff. But before that, man, you had to remember a lot of stuff. Okay, flowing retail REST, blah, 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 REST call stack, C#. Okay, following technology choices available for the code demos. Okay, so we should put the Node.js in here. So, in here, we're going to put Node.js. Node.js, and so that goes into what? Node.js. Yeah, okay, Node.js. Pretty sure I did a Nest.js one as well. Yo, Op, what's up? Hey, Nikki, you watching too? Click to view 2 comments. What does that say? No. Where do I view those? Somewhere. Window, comments and reactions. Alright. Okay, so Node.js / payment, I guess. Mostly my programming consists of educated guesses and then luck, intuition. Okay, so payment plus, what are we using? Just dropping by to see what's cooking. Dun, dun. Can you smell what the rock is cooking? Plus, what is that? Where'd that come from? I was watching EmberConf live. You know, everybody's switching to streaming their conferences live instead of doing them in person. So yeah, EmberConf. It's the Ember conference, the Ember front-end JS framework. It's in Portland, March 16, 17. So I was watching some of that on. I think it's streaming live on YouTube. This is what it looks like. Yeah, we bust it out of here. Bring it over here. Emberconf.com. I watched Nordic.js live last year. That was awesome. Awesome. Super high energy. I think with these new streaming ones, you gotta, like, it can be low enough energy when someone's in a room, you know, with people there and they like low energy, but man, you gotta really be responsible for bringing energy when it's just like someone in a room reading, I'm not saying that person was doing that, but like, I'm just saying generally, you got to be careful that you're not just like reading your presentation to a camera because it's kind of boring, you know? You got to like bring some something interesting.
Okay, let's make magic happen.
Let's get into this. Node.js. We're using Command Cloud. So Command Cloud, we know Command Cloud, and then the other thing that we used in here was Hystrix is this Netflix circuit breaker kind of library, and I used something like that in this one. What was it called? It was called Breaks. So we're going to say plus breaks. Yeah, someone asked in the Zeebe Slack the other day, today, is the community kind of more weighted towards Java rather than JavaScript? But I mean, is that a fair statement or not? I mean, sure, it's a fair statement, and sure, it's not a fair statement. It's like, it's whatever you want it to be. Like, you know, like, I mean, I wrote the JavaScript client because there was no JavaScript client for Zeebe. So it's like, is it weighted towards Java or towards JavaScript? I say it's weighted towards JavaScript. Like, I just write a client for it, and it's like I do everything in JavaScript. So for me, it's 100% JavaScript. Someone else might be like, well, you know, there's more people doing this other thing, but like, it's really what you're doing that's the main thing. Breaks and come onto cloud. And there's this other one that's like Poly, which is called Cockatiel. And so they used Hystrix here and then Poly here. I wonder if I could have used Cockatiel instead of breaks. Anyway, whatever. I used breaks, so we'll just stay with that. Stripped down version available for Golang. Okay, fail fast. A fail fast pattern using Netflix Hystrix. Fail fast is not enough. Like, how do I actually run this thing? Let's have a look. Okay, let's just like go through and update the documentation to add the Node.js stuff in, because Bernd has written this for the Java and C# things. Actually, let's try pulling in get pull upstream master. I don't know. Guessing. Nothing. Okay, good. Okay, storyline. Assume the credit card service goes nuts, meaning it still responds but very slow. Having no pattern in place, this is the worst thing that can happen, as now the payment service will call the credit card service and block until it gets a response. Okay, we're going to degenderize that pronoun. Till it gets a response. This takes a long time, comma, dependent clause. All threads from the payment service are held hostage. Hold hostile. I think this meant to say held hostage. Held hostage, comma, and the payment service will eventually time out for its clients. Okay, no apostrophe. Good. Tiny failures somewhere in your system might blow up your whole system. Tiny failures somewhere in your system might blow up your whole system. Yeah, okay, good. Java. Okay, so controllers. Yeah, okay, so that's on line 16. Okay, so we'll put the Node.js thing in here as well. Node.js. This is the Express version. And it's payment controller. Okay, version 1. Wake up. Here we go. Payment Zeebe source routes. Payment controller v1. What did we call it? Let's have a look. Okay, doesn't have a class name. Route v1. Yeah, okay, so payment controller v1. So yeah, I guess we'll just okay, controller v1. Yeah, controller v1 dot ts. Yeah, dot ts. Okay, and then we have a link to it and line 16. So I wonder, let's try following that link to the C# one and see what that looks like. Hold down control, hit plus, line 16. Okay, it's just like literally the payment controller. Go back here, line 16. Okay, so Node.js. Node.js. Not a lot of changes for me. I've been working from home for the last like last year. Yeah. So this kind of home isolation things like Node.js controller v1. Interesting now, though, that lots of people have to work from home, and it's suddenly like, oh, you could work from home, you know? Before they're like, no, you can't work from home. No, that doesn't work. Remember the last place I was working at, they were like, nah, no one can work from home. And then now everyone's working from home. So it's like, turns out you can do it if you put your mind to it. if you have to do it. You know, what is it? They say necessity is the mother of invention. Like, when you have to, you can, but when you don't have to, why would you? Why would you? Node.js, payment Zeebe, yep, routes. It's like when Brazil defaulted on their World Bank loan in like 1972 or 3 or whatever it was, and then they had to produce 93 or 96% of everything that they consumed internally because nobody would sell them anything after that. Same thing with Rhodesia after they declared unilateral independence in 1965. Suddenly they had to do everything themselves. There's a real famous story about that. They used to have these Merlin Rolls-Royce engines that every, I don't know, 250 or 25,000 hours, they had to send them back to London to be serviced, and they had to figure out how to do that service themselves, and it turned out to be when they disassembled it like a $2.50 kind of bearing that needed to be replaced. But they had to figure that out, and they were like, what? We've been sending this all the way back to London, and it's a $2.50 part. We could have done it ourselves. But yeah, it's amazing what you'll do if you have to, you know? And what you won't do if you don't have to. Why would you do even the most basic things like, I don't know, anything? Okay, so that's actually its TypeScript. Yeah, so maybe I should mention that it's TypeScript. No, whatever. Okay, Node.js. Yep. Payment Zeebe. Okay, so I got my storyline. Fail fast. Yep. Okay, payment controller v2. At least you can do as a fail fast pattern, like a circuit breaker. Okay, so in this one here, tiny failures might blow up your whole system. Okay, so what this is saying is that the second one, okay, yeah, it has a circuit breaker in it. Breaks. Okay, cool. So, I think we're in here. Yep. Okay, cool. So v2. Yeah, good, good, good. Okay, so I think this has got like the line numbers in it. Okay, so I think my line number in here is going to be line number 13. So we'll just copy this one from above, change it to version 2, and then make it here. Yeah, sometimes it's good if you foment a crisis for yourself rather than waiting for like an external crisis, but you know, whatever gets you there, I reckon. Whatever gets you there. What did I say? Line 13. Let's have a look. Line 13. Yes. Okay, good. Line 13. Okay, fail fast is not enough. Save that. Failing fast is not enough. Wow, super low bandwidth happening here, man. Rolling required bandwidth, average actual target data rate, average throughput, average required. Wonder if this is working or not. Hard to say. Difficult to say in these times. A what? Have a look. I don't know. I don't know if it's streaming well or not. Who can say? Who can say? Failing fast is not enough. So, in this example, I use the Camunda workflow engine to do the stateful retry reliably. Okay. Okay, so that will be in controller v3. Yep. Okay. There we go. Deploy the workflow. Create a worker. Yep. Okay, good. Really good example. Really good example. So, Node.js. Enter. Let's make this one a capital N. Okay. Payment controller v3. Well, no, it's called route v3, right? No, controller v2, so grab this thing here. Paste. V3. Now, let's have a look. What kind of line is this looking at? Policy. Pretty cool. I wonder if I should use cockatiel instead of using breaks. I think that would be pretty cool, actually. The reason I say that is because actually, if I have a look at, let's have a look here. Come on. Yeah. Now, if we have a look at the let's have a look at the issues for the Node client. If you have a look down here, this one opened on the 3rd of December 2019 is to investigate cockatiel. Inspired by .NET Poly. So, could be a good opportunity to close this one off. Resilience and transient fault handling library, policies like retry, circuit breaker, timeout, bulkhead isolation, fallback. .NET is Poly, a wonderful one-stop shop for all your fault handling needs. I missed having such a library for my JS projects and grew tired of copy-pasting retry logic between my projects, hence this module. Yeah, I mean, so that's like 10 seconds. It uses a raw number, which is kind of meh. Kind of cool, kind of cool. So there's either that or there's what I'm using right now, which is breaks. So if we have a look at, so this one is payment controller v3, and then if I have a look at v3 here, we're using breaks. We use it inside this worker. Like, how does breaks work? Let's have a look. Now, breaks I chose because, so I had kind of two options. I had either breaks, which is like a JS version of Hystrix, which is the Netflix library that Bernd has used in the Java example. And then there's cockatiel, which is the JS version of the Poly library that he used in the .NET example. So this is kind of stabilized. It hasn't been updated for a while. New breaks, and then it's like timeout 150 like that. New breaks, yep, timeout 150. So I might just leave it as breaks for now, and I'll make sure that I put a link to this into the doc so people can find it, and then, you know, maybe I'll use cockatiel later. This thing is pretty much built now. So the stateful retry is going to be done in the worker, which gets created on line 25. So I'll put line 25 in here. Bam. Save that. Yeah, and there's also the BPMN model to put in, but let's have a look. Go up here. Cool. So, C# payment models. Okay, so I put that one into BPMN. Ding. Okay, so if I grab that line there, copy, paste it in here, whack that in front. It's called in here. Just change this part to It's bpmn/payment v3 dot bpmn, like that. And then copy this. I don't know why I'm looking at my keyboard. It's got nothing on it. Okay. The processing just got asynchronous, which is often not wanted. In this scenario, you could very well return a synchronous response whenever the credit card service is available, but switch to asynchronicity only if it is not. HTTP supports this by differentiating the return code. Should make that supports this by differentiating the return code. Supports this through different return codes. Yeah. Via return codes. Colon. And then we can make this like this. And this one like this. The backticks make them into like a mono space font pre-formatted. Sync versus async. Okay, so payment controller v4. So if I now just grab my thing from here, this Node.js one, and then whack it in here. Boom. Controller v4. Payment v4. Now, I don't know if I sent this 202 or 204. I don't think I differentiated between that. Let's have a look. So, what do? We create a workflow instance with result. Then, yep, we return that. Otherwise, we return this. Okay, but that's status pending. So, yeah, we need to make this a 202. How does that work though? Because the way that I've written this is I create a workflow instance with result, which means that I'm awaiting it, right? So if it completes in time within the 500 milliseconds, which it's probably not going to do if it's running on Command to Cloud. Just saying, because it's just not that fast. Then it's going to return this res JSON. Otherwise, it's going to, after 500 milliseconds, time out. And then it's going to return this. Okay, so I think in that case, well, let's have a look at the implementation in C#, right? Here we go. Okay, circuit breaker. Does this have a circuit breaker in it? Yes, it does, right there. Okay, good. All good music and everything, but like I don't like it when it's got lyrics in it because it's kind of distracting to my thinking. Yo, where is it? Window. Bring all to front. Hello. Where did that go? Hello. Oh well, next track. Let's try that. I should make sure that I'm not going to get like a DCMA or what is it? Digital Millennium Copyright Act. Yeah, I could do. So, let's try. Wow, it's pretty good sound, but yeah. Let's go with the best of Shingo Nakamura. He the man, he the man. Okay, let's get back into this. Okay, so where'd my window go? Flow. This one? Yeah. Okay, so yeah, okay, so it's express, and then I want to send a status code. So express status code JSON response. Express JSON status code. Using the Googles. Okay, APIs, proper blah 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 blah. Stack Overflow, proper way to set it. Status 200 JSON response. Okay, that looks pretty easy. Yeah. Status and send. Before calling JSON, send. Status JSON. Use res status JSON instead. Res status JSON. Yeah, okay, so payment controller. Okay, so if I go back to here, back up to here, so this one here, but this, okay, so I can return a status 202 like that. Status JSON, yeah, okay. And then here, rather than throwing like that, I should do res.status 500. And then send JSON error. E.message. Oh, E to string, whatever. Like that. Okay, so it kind of fulfills on what's said here in the README file, which says return codes. Synchronous response, but switch to asynchronicity only if it is not. Okay. But how does the client get the asynchronous response back? Let's have a look. This uses semaphores. Okay. Here we go, look at that. HTTP 202. Okay. How does the client get the delayed result is my question. Okay, so there's two ways I can look at it. I can try to examine the server-side code, or I can look into the client. So I'll save that. Let's have a look at the client. So, where's the client code? Like a Stripe fake. There's like a shop somewhere. Look in here. Payment. Oh, this is for Camunda, the Camunda engine. Cool. Sehr gut. Okay, Java, yep. REST, Node.js, yeah. Now, yeah, it's cool. Now, man, what am I even looking for here? Runner? Is it in there? Nope. Close all this stuff. Goodbye. Okay, let's go. So Kafka, no. REST. Okay. So in this REST one here, we have the payments controllers. Yep. Okay. And then we have the fake Stripe. Yep. Okay. Go, we have okay. Java. Node.js. payment Zeebe. Make stripe. Reacquainting myself with the layout of this repository. Docker compose. Let's have a look at this. It's all using Kafka, so we can ignore that. I think in one of these there's like a shop. There has to be some way to run the demo, right? Okay, let's try actually reading the okay. The sample application demonstrates a simple order fulfillment system decomposed into multiple independent components. Independent. What? Yep. So comma. For example, microservices. That is to say, so it would be IE, but we can say that is to say. That is to say, microservices. And then if we're going to do that, might as well do that. Yep. Okay, so there is code. That's actually passive voice. The repository, yeah, contains code for multiple implementation alternatives to allow a broad audience to understand the code. And to compare alternatives. The table below lists these alternatives. Which table below? Okay, so in that case, if it's the table below, we can do this. A href? No, a name equals alternatives, like this. And then we go /a. Yep, alternatives. And then so, do I need to put the hash in front of it? Like that? Ah, I don't know. Alternatives. There we go, like that. Okay, lists these alternatives. Click. Click. It doesn't work. Maybe I need to put the hash in there. I'm not sure. Let's try it. Cancel that. Save it. Table below. Okay. No, I don't think that belongs there. Okay, let's continue. The example respects learnings from domain-driven design, event-driven architecture, and microservices, and should give you a very hands-on access to certain topics. And is designed to give you hands-on access to these topics. Note, the code was written in order to be explained. Hence, comma, I favored simplified code, copy and paste, over production-ready code with generic solutions. Don't consider the coding style best practice. It serves the purpose. To have easily explainable code It serves the purpose to have easily explainable code. It serves the purpose of having easily explainable code. Okay, it is purpose written to be easily explainable code. It is purpose written to be easily explainable code. There we go. Flowing retail simulates a very easy order fulfillment system. Okay, there's a picture of it there. Yep. Architecture and implementation alternatives. So, whack that in. Implementation alternatives. The most fundamental choice is to select the communication mechanism. Apache Kafka as event bus. Will easily be changed to messaging. For example, RabbitMQ. Why no picture? What happens if I do that? Doesn't exist. Okay, no problem. Okay, REST, communication between services. This example also shows how to do stateful resilience patterns like stateful retries leveraging a workflow engine. Okay. Zeebe broker doing work distribution. Having chosen that, you probably can choose the workflow engine. Having chosen that. Okay, haven't chosen the communication mechanism. So then we would say the next choice is the workflow engine. After the communication mechanism. So after the communication mechanism, the next choice is the workflow engine. No point writing code if you don't know what it is that you're coding, right? Okay, come on to BPM 7 Zeebe. Okay, so come on to cloud. So put here Zeebe hosted on Command Cloud. And the programming language, Java, Go, and this one here is really JavaScript. And when we say JavaScript, we mean TypeScript. Storyline. Flowing retail simulates a very easy order fulfillment system. I'm pretty sure I read that up here. There it is there. Okay. The business logic is separated into the services shown above, shown as context map. Shown above, dude. Okay. Well, okay, yeah. I guess we should say a context map. I don't know. Let's have a look by following the link. So open. Dun, dun. Let's check it out. Okay, many approaches to object-oriented modeling tend not to scale well when the applications grow in size and complexity. Context mapping is a general-purpose technique, part of the domain-driven design toolkit. Helps the architects and developers manage the many types of complexity they face in software development projects. Different from other well-known DDD patterns, context mapping applies to any kind of software development scenario, etc., etc., etc. Words, words, words. Okay, what else? I have no idea what I'm looking at. Ubiquitous language should be the only language used to express a model. Okay, it means language shared by everyone, so the shared conversational domain. Code's a primary form of expression of the model. Other artifacts, bounded context, setting in which a word or statement appears that determines its meaning. Context dependent. Size, shape, characteristics, same term, different meaning. Yep. First context map, same concept, different use. Okay. Conclusion, put A in front of it. Yep. Long-running services and orchestration. Some services are long-running in nature, as e.g., yeah, it kind of doesn't parse in modern English that so well. Some services are long-running in nature, like, for example, the payment service, which asks for, you know, or you could say, for example, the payment service like that. Yeah. Okay, so, for example... But in order to construct that, we would need to, let's have a look. For example, long running in nature. So here we would need to do this. For example, the payment, in that case, what we would do here is we would use a colon. For example, the payment service asks customers to update expired credit cards. Hence, a workflow engine is used to persist and control. And we just say this. A workflow engine. A workflow engine is used to persist and control these long-running interactions. Workflows live within service boundaries. An important thought is that the state machine, a workflow engine in this case, is a library used within one service. An important thought. If different services need a workflow engine, they potentially run multiple engines. This way, it is an autonomous team decision if they want to use some framework and which one. An important thought, so it's kind of like a crucial aspect or an important characteristic. Important aspect. An important aspect is that this state machine, so an important aspect is that this state machine is a library used within one service. Okay, so an important aspect is it's important to note. That's it. That's passive. So in that case, we should change it to imperative. We just say note that this state machine or workflow engine in this case is a library used within one service. Note that the state machine or workflow engine in this case is a library used within one service. If different services need a workflow engine, they potentially run multiple engines. They can potentially it's not just multiple engines. If different services need a workflow engine, they can run whatever engine they want. Whatever engine they want. This way, it is an autonomous team decision if they want to use some framework and which one. Okay, events and commands. Okay. Resilience patterns for synchronous communication. Depending on the means of communication, for example, messaging versus blocking, synchronous REST calls. E.g. Yeah. Yeah, for example, messaging versus blocking synchronous REST calls. And then here, I guess we could say async messaging. Asynchronous messaging versus blocking synchronous REST calls. Depending on the means of communication, you also have to tackle quite basic communication problems, such as, for example, okay, it's not such as, you also have to deal with well, I think the point being made here is that you have to deal with basic communications problems no matter what. And then depending on the means of communication is how you structure that. So really it's like you also have to deal with basic communications problems, right? Kind of inverting the sense of this, but I think this is the sense of it. You also have to deal with the underlying communications, basic communications problems, which depend on the specifics of which that might be a bit too passive. Depend on the means of communication. You also have to deal with basic communications problems, specifics of which depend on the means of communication. You know, for example, asynchronous messaging versus blocking synchronous REST calls. Okay, so you might use stateful retries for this. Okay, we'll say you might use stateful retries. You might use stateful retries. See the rest example. Links and background reading. Okay, good. Okay, so that was like this readme. So now we look at this readme. Is that the readme? No, this readme. REST. The REST readme. Okay. Right. Okay. Flowing retail REST. This folder contains services that connect via REST, representational state transfer. Currently, this is reduced to showcasing resilience patterns. Sure. Sample service demonstrating stateful resilience patterns in a REST environment. This sample microservice can retrieve payments, therefore needs to be called via REST. I don't see how that follows. Requires an upstream. Okay, the sample REST microservice it's kind of like it's a REST microservice can retrieve payments. Can retrieve payments. This thing is more like, I mean, we're doing a put to create a payment. So we're creating a payment. Yeah, representational state transfer. Yeah. It's almost more like RPC because it's remote procedure call. Sample REST microservice can retrieve payments. It's more like it can affect payments. It affects payments. Affects payments in response to a put. In response to a put call. It requires an upstream REST service that charges credit cards. Okay. Okay. The simple call chain is great to demonstrate various important resilient patterns. This simple call chain is great to demonstrate various important resilience. Is great for demonstrating is this simple call chain is perfect for demonstrating important. Yeah, okay, so we'll just say this. It's perfect for demonstrating it's like it's sufficiently complex but no more. Okay. There are the following technology choices available. So you could just say the following technology choices are available. That switches it from passive to are choices. There are the following. No, it's still passive. The following technology choices are available for the code demos. There are the following available. Yeah, I'm not sure what that is. It takes it from like abstract conceptual to still passive, but whatever. Java, Spring, Hystrix, Camunda. C#, Poly, Camunda. Node.js, Breaks, Camunda Cloud. Zeebe. Ta-da! There's a stripped down version available for Golang. So I think we should hyphenate that. Storyline. C fail fast is not enough. Assume the credit card service goes nuts, meaning it still responds but very slow. Okay, so assume having no pattern in place. This is the worst thing that can happen. So let's assume a scenario where the credit card service goes. So you could say like this. Let's assume a scenario where, and it's the upstream, downstream. So we'll call it downstream, upstream, we'll call it upstream, downstream, we'll call it downstream. Credit card service still responds, but very slow. No failure, no resilience pattern. With no resilience pattern in place, resilience. This is the worst thing that can happen. This is the worst thing that can happen. Now the payment service will call the credit card service and block until it gets a response. If this takes a long time, all threads from the payment service are held hostage. And the payment service will eventually time out for its clients. Not on Node.js, but whatever. Tiny failures somewhere in your system might blow up your whole system. Fail fast. The least you have to do is apply a fail fast pattern like circuit breaker. In this example I use Netflix Hystrix. So use Netflix Hystrix. Yep. And Poly for C#, breaks, for node. Which provide equivalent functionality. Functionality, yo. Okay, the least you have to do. Sort of like, I guess you say the minimum. It's kind of like the minimum effective dose of architecture. The minimum effective architecture, the least you have to do. Like, I guess you say a simple, what would you say? A simple mitigation. It's like this, a simple mitigation. Naive mitigation. Simple mitigation and naive mitigation is to apply a fail-fast pattern like circle breaker. Yeah, simple mitigation. If a service responds, and then we should like make this here italic so people are like, I'll skip over that. If a service responds to slow the circuit break too slow, if a service responds so too slowly, the circuit breaker interrupts and the payment service gets a failure right away. This way you make sure the overall system is still responding even if functionality degrades. You know, meaning meaning we can't charge credit cards. Yeah, then there's a question of whether that, you know, really, if is there any real meaning to the service running? I mean, at least you can return an error message in a timely fashion, I guess. Okay, even if the functionality degrades, meaning we cannot charge credit cards. Java, C#, Node.js. Fail fast is not enough, but failing fast is not enough. Often, frequently, so if we're going to say very often, we can say often, or we can say frequently, or in many cases, frequently. Let's try frequently. Frequently, a retry after the credit card service has been fixed resolves the situation. After the credit card service returns, has been fixed. After retrying after the credit card service returns to normal, resolves a retry after the credit card service has been fixed resolves the situation. This retry needs to be stateful to not only retry right away, but again in a couple of minutes, hours, or even days. Having the stateful retrying as possibility keeps the failure handling local to payment, making the whole architecture less complex. Having the stateful retrying as possibility keeps the failure handling local to payment, making the whole architecture. Okay, so put this to the payment service. Having the stateful retrying as possibility keeps the failure handling local to the payment service. Having the stateful, so we would say having the stateful retrying local to the payment service makes the whole architecture having the stateful, so I'd say as part of the failure handling, having the stateful retrying, the stateful retry is part of the failure handling local to the payment service. Having this stateful retry as part of the failure handling local to the payment service. Okay, this is like a triple there, and then you got makes the whole architecture less complex. So let me collapse this. Having the stateful retry as part of the failure handling local to the payment service. Having the stateful retry as part of the payment service's failure handling. Having the stateful retry in the payment service as part of its local failure handling. Maybe I could just chop this out like that. Having this stateful retry local to the payment service makes the whole architecture less complex. Having this stateful retry local to the payment service makes the whole architecture less complex. Less complex than what? Makes the whole architecture. Keeps the entire system architecture. Reduces the complexity. Reduces overall system complexity. Having this stateful retry local to the payment service reduces overall system complexity. System architectural complexity. Having this stateful retry. So keeping the stateful retry local to the payment service reduces overall architectural complexity. Wah, that wasn't the right one to hit there. Okay, let's have a look. In the example, I use the Camunda workflow engine to do the stateful retry reliably. The Camunda workflow engine, okay, or Zeebe in Camunda Cloud. Okay. Keep synchronous responses. Okay. The processing just got asynchronous, which is often not wanted. In this scenario, you could very well return a synchronous response whenever the credit card service is available, but switch to asynchronicity when it is not. So, when it is not. Like that. HTTP supports this via return codes. 200 OK means all OK. 202 accepted means I call you back later. I call you back later. Let's say I'll call you back later. Like that. Sync versus async. Okay. Ending. So version 4. The workflow is created by the Java DSL. Yeah, I discovered that the other day. Payment before BPMN. Node.js. It's there. Asynchronous work distribution without messaging. An alternative to synchronously calling an upstream service. Okay, so it's upstream and I call it downstream up here. So I've got to normalize that. So where did I write that? It was prior to this. Downstream. Here we go. And that needs to be upstream. The upstream credit card service. Okay. Asynchronous work distribution without messaging. An alternative to synchronously calling an upstream service is to communicate asynchronously. The default would be messaging. Okay, so you can send these asynchronous messages. In this example, comma, I show one alternative which a lot of customers use very successfully. Tremendous. Who sees in there? Yeah. Using the workflow, in this example, I show an alternative So you could say, this example shows an alternative that I've seen a lot of customers use very successfully. In this example, I show one. So this example demonstrates. So you could, to tighten it, this example shows an alternative, an approach. So, okay, just reduce the layers of conceptual indirection. Shows an approach that a lot of customers use very successfully, using a workflow engine as work distribution. That a lot of customers, many customers use, that a lot of customers use very successfully. So a lot of customers use very successfully. It's a lot of superlatives. This example shows an approach that customers use successfully. That shows an approach that shows, so you could do it like this, shows a successful approach used by many customers. So he'd say used by many customers. This example shows a successful approach used by many customers. Taken, because we're going to say using. This example shows a successful approach taken by many customers using the workflow engine as work distribution, behaving like a queue. Okay. This leverages a concept. So it's not even a concept. This leverages a pattern. Pattern called external tasks. This leverages the external task pattern. Yeah, so you can, the external tasks pattern, microservices Java. Yep, worker in Java. Skipped v5 and directly implemented v6. Oh, what? I don't have that version in mine. Payment Zeebe, source, routes. We only went up to v4. What does v6 do? Dude. Am I going to have to write v6? Let's get rid of this. Let's have a look. Skipped v5, went straight to v6. Okay. There it is there. Payment controller v6. Models. There it is there. Open BPMN modeler. Okay, cool. Oh, okay. Dude, it's got like a compensation, I think that is. Compensation. Yo, okay. How am I going to do this in Zeebe with Command Cloud? Okay. Compensation, yeah. Okay, there's a worker Node.js there. That's with Commanda. Yikes. Okay, here comes the challenge. Good. Business transactions. And then payment v6. Okay, it goes straight to v6 here for the workflow, how to run. Okay. Okay, so yeah. How to run in Node.js, yo. I've actually got two versions of the Node.js one. Got Node.js Nest and okay, so if I collapse this, let's have a look. Bam. Node.js, payment Zeebe, readme. Readme.md. Okay. C# payment. Let's have a look. C# payment. Yeah. What? C# payment readme.md. Wow, man, this is like fully featured, yo. Okay. So, yeah, this here should have readme on it. Okay, click on that. Does that work? Yep, that one works. Okay, but the other one doesn't work. So Java/payment. So REST Java. Okay, you got two. You got payment Commanda and payment Zeebe. Okay. Okay, so that's. Okay, so you got this. Commanda. Okay. Dude, this is epic. Epic. Oh man, implementing this in Zeebe. Yeah, okay, yeah, challenge accepted. We can do it. We could use an error, a BPMN error event. Okay, yeah, okay, so here's the, which one am I looking at here? I'm looking at what? This? This? Yeah, okay, so I need to update my Node.js README here. Yeah, okay, it needs to have like a little bit more data in it. For example, if we open the how to run, so if I open the C# one, okay, .NET version of Flowing Retail REST. Okay, so in here, payment. Yeah, okay, so this is like, this other one says payment Zeebe readme. Okay. Split the screen. Get rid of this. Goodbye. Switch to this one. Yeah. Okay, so this one is Node.js Express version. Flowing retail latest. Ah, man, I'm hungry. I'm going to take a break, I think. Flowing retail rest. Okay, this example, I'm just going to copy this like word for word, hey? This example demonstrates, if I'm going to do that, I can just go like this. Like this, copy and paste. See, introduction for the storyline patterns behind this demo. Yep, full stop. Concrete technologies frameworks in this folder. Boom, here we go. So, we're using TypeScript. Okay, so we're using like Node.js. TypeScript. We're using breaks. And then we're going to use Zeebe on Command to Cloud. Epic. Dude. Super epic. Okay. Okay. I'm gonna take a break for a little while. And what are we at? We're at 3:30, so yeah, I'm gonna come back and continue in like 10-15 minutes.